polynomial division and real zeros of polynomials. What are we talking about? Mr. Mitchell, you're using a lot of fancy words, like polynomial. Can you clarify? What is a polynomial? Let's start with that. A polynomial is any equation that is written like this. It has a coefficient. We're going to call this an, some number, times x to a power. This could be like 2x squared, or 9x cubed, or negative 3x to the 7th power, right? A polynomial is just equations that have coefficients and exponents. Coefficients and a variable and an exponent, like these. Those are polynomials. And a polynomial can have as many of these as it wants. I'm going to have the next one, an minus 1, x to the n minus 1. This just means I start at some biggest exponent, and I get the next exponent down. Right? If this was a 7, this would be 6. Right? If this was a 2, my next one would be 1. Plus 5x, right? Or this would be minus 2x squared. Right? I start with the biggest and I go down. Start with the biggest, go down by 1. Plus 1x to the 6th power. Right? I just go down by 1. So I start with an exponent, down by 1, and I go follow this pattern, n minus 2, x to the n minus 2, plus dot dot dot. I follow that pattern until I get to the end. A 1x to the first power plus a 0. Plus dot dot dot, right? Plus 1. This could be plus 6x plus 5 minus x to the 5th power plus x to the 4th power minus x to the 3rd power plus x to the 2nd power minus x plus 9. All right, all of these, I should put this 1 over here. All of these just follow the same pattern, plus 1. Right, they start at a certain exponent and they keep going until they hit a number on the end. All of these are polynomials. Number on the end. Number on the end. Right? So they have these different pieces. This a sub n, this is a coefficient. Specifically, we call this one the leading coefficient. Whoa. We call it the leading coefficient. It's the first coefficient. But all these are coefficients. And we have this exponent here, this n. This exponent, we call this the degree. And the degree, that's just the biggest exponent. Is called the degree. And that's a polynomial. Right? It is an equation that has Oh, I should do one more thing. One more piece of language. These two pieces together, the coefficient part and the variable part, this is called a term. A coefficient times a variable, right? So this 2x squared is a term. 2x squared is a term. 5x is a term. All these are terms. All the pieces, like each sort of like grouping, each grouping we call that a term. So a polynomial is an equation that has what should I say? That has many terms added together that starts with the biggest exponent and goes down from there. Goes down to a constant. That is a polynomial. You've seen these before. A quadratic is a polynomial, right? X cubed is a polynomial. All of these are polynomials. It's a simple type of equation. It's a family of equations. And we can do a lot of things with these equations. A lot of things are really, there's a lot of important things about polynomials that we're going to figure out. Okay. A lot of things about polynomials we're going to try to figure out. Okay? So the definition of a polynomial is an equation that has many terms added together. It starts with the biggest exponent that we call the degree. Biggest exponent that we call the degree. And goes down to a constant. Right? Starts at some exponent, goes all the way down. And you don't have to have all of them. You can skip some. Like I can do y equals x to the fifth power, what's happening here? Fifth power plus x to the second power plus 2. That's fine. Or I can say y equals x squared plus 7x. I can skip the constant part, right? But you start at the biggest and you keep going down until you're done. All of these are types of polynomial equations. These are types of polynomials. For example. So this is a category of equation. And the important thing about polynomials, right? Well, one of the important things. We talk here about real zeros. Zeros of a polynomial. So I want to say down here, one thing about polynomials, important fact, all polynomials have zeros. Why is this such a big number? Zeros. By zeros, we mean a few things. Zeros are also things called roots. They're also called x-intercepts or solutions. Goodness gracious. They're also called solutions. And they're also called factors. But all polynomials have places where they touch this x-axis. These are what we call zeros. Zeros, roots, factors, solutions. These places where it crosses the x-intercept, the x-axis, these are those roots. And all polynomials have these. All polynomials have zeros, or roots, or factors. Okay? Our job is going to be trying to find them. Our job is to find these zeros. It's an important thing to do with polynomials, how to find these zeros. Okay? Important thing to do. And one way we do that is by dividing. Whoop. Our goal is to find those roots. Find the roots of a polynomial. Whoop. Draw a little bit better box here. Find the roots of a polynomial. And one way we do that is with division. So I'm going to show you how do we divide polynomials. Division. How do we divide polynomials? So first of all, let me ask you, what is, if I asked you to factor this number, 42. How do I break 42 apart, right? Well, 42, I know that 42, I can divide it by what? What can I divide 42 by evenly? Break 42. What numbers multiply together to make 42? 7 and 6? Great, 7 times 6. Well, 6, I can break 6 apart even more, right? 6 can get broken up. 6 is 3 times 2, right? Yeah. So when I factor a number, right, I get these pieces here. These are the factors. Right? The things that multiply together to make 42. Obviously 1, 7 is 7 times 1. I could do this forever, right? But I skip over 1. I look for the factors of 42. All right. Well, I can do the same thing for a polynomial. Let's say I have an equation like, I don't know, 6x cubed minus 19x squared plus 16x minus 4. What? How do I break this apart into pieces? What do those pieces even look like? This number I was able to break apart into these factored pieces, these single digits. With a polynomial, when you factor a polynomial, what you're going to get is a bunch of parentheses with x plus something. X plus something. X plus something. And these somethings here, these question mark numbers, I'm just in a different color, these question marks here, these are going to be the factors. These are my factors. And the cool thing about polynomials is because there is a power of 3, I know that this is going to have 3 factors. So how do I do this? How do I break this apart? How do I get this equation into these 3 pieces? That's our goal, right? 3 factors because the degree, or exponent, is 3. Here, right? That was bad. Let's try this again. 3 factors because our degree is 3. These are the factors. All right, 3 numbers, 3 unknown pieces. They all have this parenthesis, right? We're looking for these parenthesis pieces because we know if we multiply, right? If we multiply these 3 parentheses together, we get a polynomial equation. We get this kind of equation, and so we can break it apart. We get these pieces here. So polynomials are made from these little chunks, these little factor pieces. Multiply these factors together, you get a whole big equation, a whole big polynomial equation, right? Multiply these 3 things together, you get this thing. Just like the 42, just like the numbers are multiplied together, these 3 pieces make this unique number, right? These are the only pieces that make this. No other combination is going to make 42. This is exactly the right combination, and no other combination is going to make anything but 42, right? If you had different numbers here, you'd have a different outcome. So it's like exactly paired. Same thing with polynomials. Polynomials have exactly one group of factors, one group of numbers that make that polynomial. Same kind of way. Same kind of thing. So like a factor, right, we do this by dividing. 42, we divide it into 2 things and multiply together to make it, right? Divide the number. So how do I divide polynomials? Let me show you. How do we divide polynomials? Divide polynomial. I want to take this 6x cubed number, right? I want to take 6x cubed minus 19x squared plus 16x minus 4, right? And I want to divide by, let's say, x minus 2. So we're going to do long division. Polynomial. This is going to be long division. So you have this equation, you have this long division problem, you have this big polynomial, put it inside, right, big polynomial, put it inside a long division, and put the thing you're dividing by, right, this is the divisor, call that the divisor, x minus 2. This is the dividend, but our divisor, the thing we're dividing by, like a long division problem. So how does long division work, right? Let's look at 42 and 7, or let's do 42 and 2. So let's look at 42. And let's take 42 and let's divide it by let's say 3. How do we do long division, right? Well, with long division, the thing we ask is how many times does 3 multiply together to make 4? Long division, we say how many times does 3, how many 3's do I need to make a 4? How many 3's do I need? I only need 1 3, right? I need 1. So I'm going to put 1 3, I'm going to put 1 on top, right, because I'm taking 1 3. And then I bring the 3 down, right? I bring the 3. I say minus 3 times 1. I multiply these, right? Multiply those together. 3 times 1 is 3. And I subtract, right? 4 minus 3 becomes a 1. And I bring down the 2. And now I have 12. So we have 1 3. 3 times 1 is 3. Subtract those numbers and get our leftover piece. Then I bring the 2 down. And I ask now, again, the same question. How many 3's? How many 3's do I need to go into 12? How many 3's make 12? 4 12, right? 4. So it's 3 times 4. So I'm going to multiply. I put the 4 up here. Multiply 4 times 3. That makes 12 here. Subtract, and I get 0. And this is my remainder. Right? That's long division. So my answer here is a remainder of 0. My answer is 3 goes into 42 14 times with a remainder of 0. Right? Let me put that in blue actually. Right? So this is my answer. 14 times with a remainder of 0. Right? And that's long division. We will do the same thing, the exact same thing with this equation here. When you do long division with polynomials, what you're asking is, you're looking at the first number only. You only care about the x and this part here. And you ask, one question is, how many x's do you need to make them match? How many x's do I need? If I have right here, if I have x, one x is this is just x by itself, and I need x cubed, right? What do I need? How many x's do I need to multiply this 1x by to make it into x cubed? How many more x's do I need? Right? Well, I have 1 here, I have 3 here. I need 2 more x's. Right? I need 2 more x's to make x cubed. If I have x to the first power, right, this x is to the first power, I need 2 more x's to make x cubed. So I'm going to put x squared up here. Right? The other thing I need is how many numbers. How do I make the numbers match? I have a 1 here. I have a 6 here. What do I need to multiply this x by to make it into 6x cubed? I need to multiply by 6x squared. I need 6x squared. If I multiply 6x squared times this 1x here, I'm going to make it match. I want to make it match exactly, because I want to get rid of it. Just like we had right? I want to get rid of the whole thing. So 6x squared to make my x match the 6x cubed. Right? 6x squared times this makes 6x cubed. And now, what we have here, we don't just have the 1 though, we have this whole piece. And this whole piece here. So what I need to do is multiply multiply by, I should say multiply the whole thing, the whole piece, maybe I should say multiply the whole divisor by the matching part. So I'm going to take this 6x squared, and I'm going to multiply this whole thing times 6x squared. I'm going to write that down here because I'm matching these two pieces, right? These two pieces match two pieces here. Right? These two pieces, there's two pieces here, and they go with these two pieces here. So if I multiply 6x squared times x, 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. I multiply it by both pieces. This x minus 2, this is what I'm dividing by. So like the problem would be, for example, where am I going to write this? The problem would be, for example, this takes too long to erase. The question might be divide 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. God, why is this so bad at writing? Divided by x minus 2. This would be the question, for example. This is the question. Divide those two. And so the x minus 2 is given to you in the problem. It's part of the question, right? What do you divide by? 16x. This is the part, right? When you divide by that number, that's the part you use. So it's part of the question. It's part of the question. And so we get this x minus 2 because that's what we're dividing by, right? We're dividing by x minus 2. So you ask how many times does x, what do I need to multiply x by to make it into 6x cubed? And I need to multiply by 6x squared. Then I take that 6x squared, multiply both things. 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. I take those and subtract. Whoa. Subtract. Subtract. Just like long division, you do your multiply. How many times? Multiply these, and then subtract. 6x cubed minus 6x cubed, these two things will go away. This goes away and this goes away. Okay, but the 19 and the 12x, these have to subtract. Now this subtraction, remember about this how subtraction works. I need to distribute my subtraction to both. That negative gets distributed. So when you subtract, do not forget, distribute the negative. So minus 6x, and minus minus, this becomes plus 12x squared. Minus negative 12, minus minus becomes plus 12x squared. So negative 19 plus 12, that's going to make negative 7x squared. Right? Negative 7x squared. I did the subtraction. I got my answer. The first part canceled. They'll always cancel because we made them cancel. These first pieces are always going to cancel because we made it that. We made them cancel. We want them to cancel. They have to cancel. We made those cancel. And this other part, well, we just have to deal with the repercussions. This is the leftovers, right? We don't look at this 2, whatever happens to it, that's just what happens. We got to deal with it. So we subtracted these. Negative 19 minus negative 12, right? Minus becomes plus 12. Negative 19 plus 12 is negative 7x squared. That's the x squared piece. And now, just like long division, I take this piece and bring it down. Plus 16x. And I do it again. Bring down. And back up to how many x's do I need to get those two the same. And now the part I'm looking at, is I want this x to be equal to negative 7x squared. I need my x to match negative 7x squared. So what number do I need in front? I need negative 7 in front. So it's going to be negative 7. How many x's do I need? If I've got 1 x, I need 2 x's. I need 1 more x. So that's negative 7x. Ooh. X. So I'm doing long division. Right, we're looking at the front number. We look at this first number. Right, here's our 2 numbers. Here's our first number here. We want those numbers to match. How does my negative 7x, how does my x become negative 7x? Multiply by negative 7. And I need 1 more x. Negative 7x. And now I take negative 7x and multiply. Negative 7x times x is negative 7x squared. Always matching. Negative 7x times negative 2 is going to be plus 14x. And put your parentheses and subtract. Same process as before. Oh, red. Right? Take the process and subtract. Don't forget, take your negative, distribute it. Distribute that negative. Distribute the negative to these 2 things. So this becomes plus 7x squared minus 14x. Distribute that negative, right? It was plus 14. Give it a negative, becomes minus 14. 7x's cancel. 16 minus 14x is 2x. And bring down minus, minus 4. Bring down the negative 4. Okay. And then we do it one more time. One more time. We look at the 2x, right? We look at the first piece. How do we make how do we make x into 2x? What do we multiply x by? What do we multiply x to make it into 2x? By 2, exactly, right? X times 2. So we put plus 2, because we're multiplying by a positive 2. And then we do our multiplication. 2 times x is going to be 2x. 2 times negative 2 is negative 4. And subtract those. Again, distribute the negative, plus, minus, plus. Change all the signs. Change all the signs. If that was a plus, change it into a minus, change the minus into a plus. And subtract. 2x minus 2x goes away. 4 minus 4, those go away. So my remainder is 0. So my answer to this problem, the answer is, I get this top part up here. This is my answer. That's my equation that I divided and I got. The answer was 6x squared minus 7x plus 2, remainder 0. So I just divided a polynomial. We just did that division, crazy complicated looking equation, divided a polynomial into smaller pieces. How are you feeling, everybody? Does that feel good? It's long. Remember, this is like 4th grade. It's like 4th grade, everybody. It's long division. Come on, you've been doing this for like 10 years. Well, yeah, that's because you're in 11th or 12th grade now. A little bit better. So what I want to remind you of, right? What we did. This 6x cubed minus 19x squared plus 16x minus 4. What we did was we factored this into these two pieces, right? We did x minus 2 times 6x squared minus 7x plus 2. These two pieces, right, if I multiplied these two things together, it would become this bigger equation here. And that's what we're doing. We're taking this big equation and we're breaking it apart into smaller pieces. That's what this factoring does. That's what this division allows us to do. Take this equation here and factor it into these pieces down here. Okay? X minus 2, because that was the thing we divided by, right? It's this x minus 2 times this up here. These two things multiply together to make this bigger part. That's what division does, right? That's what this long division does. Breaks it apart into smaller pieces. Okay? Should we try one more? Let's try one more. What if I gave you something like the following? Here's another example. What if we did something like divide x squared plus 3x plus 5 divided by x plus 1. Here's what I want to divide, right? So I'm going to set up my long division. X plus 1 on the outside divided by x squared plus 3x plus 5. Set up your long division. And if we never grow with using x's and exponents, what are we even doing? Keep your mind keep expanding it, like that graph we saw, like the Mandelbrot said, like the Mandelbrot graph. Just keep expanding, keep growing, right. That's life, everyone. That's life. All right. Again, we have this equation here, right? Set up my division. I divide this big one by x plus 1. So again, we look only at the first pieces. I want to make x match x squared. Okay? We got 10 minutes, Jericho. Slow your roll. We want to make x match x squared. What do I need to multiply x by? What do I need to multiply x by to make it into x squared? What do I multiply x by to make it into x squared? Well, I don't have a number, but yeah, I'm only missing x's. So I'm going to put x up here. And then I multiply. X times x is x squared. X times 1 is plus 1x. 1x. That's a 1 there. And then I subtract. I make sure I change all my signs. Plus, this is a minus, and this is a minus. Very important to change your signs. If you don't, everything gets all messed up. So flip all my signs. Then I see x minus x goes away. 3x minus 1x is 2x. And I bring down the 5. So now I want to get my same thing. I repeat my process again. I look at this x. I see what do I multiply x by to make it into 2x? What do I multiply x by to make it into 2x? Well, x, I need a 2, right? I'm missing a 2. So plus 2. Right? 2 times x, that's going to make this into a 2x. 2 times 1 is plus 2. And I subtract. I change all my signs. Plus, that's a minus 2x. That's a minus 2. I do my subtraction. 2 minus 2 goes away. 5 minus 2 is 3. And I'm out of pieces. So this 3, this is my remainder. That's my remainder. So with remainders, I have to do something a little different. My answer is going to look like this. It's the top part here, x plus 2, right? X plus 2, the regular answer I got, x plus 2. But since I have a remainder, I have to do something a little different. I need to take the remainder and I add it to the equation 3, right? My remainder's up here, remainder up here. And I divide it by x plus 1. This was my divisor. The thing I divided by over here, that's that x plus 1. My dividing part, the thing I'm doing the dividing by, needs to be the denominator of my remainder. And this is the answer. Your remainder goes over like a fraction. Remainder goes over like a fraction. Like this. Right? The remainder part, whatever the remainder is the top of the fraction. Bottom of the fraction is the thing you are dividing by. You're dividing. Okay? So, long division, everybody. Take a polynomial, divide it by a number, right, work it out. I got 5 minutes, right? I want to make sure. 20 or 25? 25, great, 5 minutes, perfect. Enough time to do one last example before you're going to try these on your own. One last example. Last thing that's important to remember. What if I had something like 2x cubed plus 6x minus 3 divided by, x plus 1. No, x minus 1. X minus 1. What if I had this problem here? Same thing. Another example. Take this problem, set it up like a division. X minus 1 on the outside, divided by 2x cubed but there's a problem here. In this equation, I am missing the x squared piece. You see what happens? I have the x cubed. I have x to the first power, but I don't have an x squared number. Right? There's no term. That's the squared term. I skip it over. But I am not allowed to have a space. Not allowed to miss numbers. I'm not allowed to skip. So if I have a missing number, I need to fill it in with a 0 x squared. And then I can continue, plus 6x minus 3. I need to fill in missing pieces, fill in missing pieces with zeros. So if I'm missing an x squared part, if I'm missing any other pieces, however many pieces I'm missing, I need to fill in every space, fill in every number. I need a cube, a squared, a first, a 0. Or I need a 4, a 3, a 2, a 1, a 0. I need every part. You are not allowed to have any missing pieces. You cannot have any missing pieces in here. I need a cube, a squared, a 1, a 0. I need all the parts. So if you're missing any pieces, fill them in with zeros. Fill in those missing pieces with zeros. And then do your division regular. Right? If I have x, I want to make 2x cubed. I need 2x squared. Multiply those, 2x squared times 2x, that's to 2x cubed minus 2x squared. And then I subtract. Switch all my signs. Those cancel. 0 plus 2x squared is 2x squared plus 6x. Bring it down. And again, look at the first number. X into 2x squared. Well, I need a plus 2x there. And that makes 2x squared. 2x times 1 is minus 2x. I subtract. put your parentheses, and flip all the signs. Cancel those. 6 plus 2 is 8x. Bring down the 3, minus 3. 8x and x, I need a plus 8 there. Plus 8 there. 8 times x is 8x. So this is just a process, everyone. 8 times 1 is negative 8. Subtract those. Flip all my signs. 8's cancel. Negative 3 plus 8 is 5. That's my remainder. So my answer is going to be 2x squared plus 2x plus 8 plus my remainder over x minus 1. Your homework tonight. Your homework, everyone. Page, I'm going to put this on Schoology. Page 127. Numbers 1 through, I wanted you to do 11. 1 through 11, odd. That's it. Plus quiz on IXL. Don't forget your quiz. Don't forget your assignment. I'll put that on Schoology. Due on Friday. I'll see you all later. Type goodbye in the chat. Once you type goodbye, you are free to go. Have a wonderful day. Catch you all later.